Hey science enthusiasts, welcome back. Today we're diving deep into the microscopic world of viruses and bacteria. Picture this, two microscopic entities invisible to the naked eye, yet they play such significant roles in our lives. First up, we have viruses. These genetic hijackers, as we like to call them, are not even alive in the traditional sense. They need a host to replicate, much like a parasite. Now meet bacteria, single-celled organisms that are fully capable of living independently. They have everything they need to survive and reproduce, all wrapped up in one tiny cell. So, while both are minuscule and can cause diseases, they are fundamentally different. Viruses, the hijackers, need us to thrive, while bacteria, the lone rangers, can go it alone. Intriguing, isn't it? But that's just scratching the surface. But wait, the plot thickens. Take a look at these structures. Viruses have a straightforward design. Picture a microscopic pirate ship. The genetic material serves as the treasure, cloaked in a protein coat, the ship. But here's the twist. These pirates can't sail alone. They need a host cell to reproduce. It's a bit like a pirate needing a captive to steer the ship. Now imagine bacteria as tiny autonomous submarines. They're single-celled organisms, complete with their own genetic material, ready to multiply at will. Unlike the pirate viruses, these submarines can navigate the vast ocean of life on their own, reproducing independently. This process is known as binary fission, where one cell divides into two identical daughter cells, all without a host. So, while viruses are like hijackers, relying on a host to replicate, bacteria are lone navigators, capable of charting their own course. On the other hand, bacteria are more like tiny living cells, capable of reproducing independently through binary fission. Now let's talk about the impact on humans. Viruses and bacteria, these tiny entities, hold immense power to affect our health. Viruses, often the culprits behind our common colds and flus, are notorious for their ability to invade our cells and cause infections. They can lead to more severe diseases too, like COVID-19, demonstrating their potential to trigger global health crises. Bacteria, on the other hand, have a more nuanced role in our lives. Sure, some bacteria are harmful, causing ailments like strep throat or urinary tract infections. But here's the twist. Not all bacteria are bad news. In fact, many are essential for our well-being. They reside in our bodies, aiding in processes like digestion and vitamin production. So while we often associate these microscopic entities with disease and discomfort, it's worth remembering that they're not all villains. While some can cause infections like strep throat or urinary tract infections, others play essential roles in our bodies. Enter the heroes, the beneficial bacteria in our bodies. These microscopic allies are far from being the villains some might expect. In fact, they're some of our body's closest friends. Living in harmony with us, these bacteria, particularly those in our gut, are silent champions of our health. Consider the complex process of digestion. It's not just us doing all the work. These beneficial bacteria break down food particles that our body can't handle alone. They're like our personal chefs, preparing and breaking down our meals into simpler ingredients that our body can easily absorb. But that's not all. They also play a crucial role as tiny vitamin factories, producing essential vitamins like vitamin K and certain B vitamins. If that wasn't enough, they also moonlight as bodyguards, helping to regulate our immune system, keeping it balanced and ready to protect us from harmful invaders. These friendly microbes aid in digestion, produce essential vitamins, and even play a role in regulating our immune system. Speaking of the immune system, let's discuss how it deals with viruses and bacteria. Imagine a battlefield. On one side are the invaders, viruses and harmful bacteria. On the other side, our immune system's valiant soldiers, white blood cells, antibodies, and a host of other components. When a virus enters the body, it attempts to hijack our cells to replicate. In response, our immune system springs into action. White blood cells, such as macrophages, engulf the invaders, while T cells destroy infected cells. At the same time, B cells produce antibodies, specialized proteins that latch onto the viruses, marking them for destruction. The battle against bacteria is similar, with the immune system seeking out and neutralizing these microscopic intruders. And so, amidst this microscopic war, our immune system emerges as a formidable defender, with white blood cells, antibodies, and other components working tirelessly to neutralize and eliminate both viruses and harmful bacteria. When the going gets tough, we turn to medicine. In our war against microscopic invaders, we have two primary weapons: antibiotics and antivirals. Let's start with antibiotics. These are powerful drugs, specifically designed to kill bacteria or halt their growth, effectively ending their invasion. They're the knights in shining armor when we're dealing with bacterial infections. But here's the rub. Antibiotics are a no-go when it comes to viral infections. Why? Because viruses are not alive in the traditional sense, and they inhabit our own cells to replicate. So, what do we use against viruses? Enter antivirals. These drugs work not by killing the virus, but by disrupting its replication process. However, due to the unique and complex nature of viruses, developing effective antivirals can be a bit like solving a molecular puzzle. For viral infections, we have antivirals, although they're often more challenging to develop due to the nature of how viruses replicate. Let's zoom into our gut for a moment. Inside, there's a bustling metropolis of microorganisms, known as our microbiome. This community, largely made up of bacteria, plays a crucial role in our health. They help break down food, produce vitamins, and even influence our immune system. It's a delicate balance, and maintaining it is key to our well-being. But what happens when this balance is disrupted? Research shows that an imbalance in our microbiome, known as dysbiosis, can lead to a host of health issues. These range from digestive problems like irritable bowel syndrome to autoimmune disorders and even mental health conditions such as depression and anxiety. So, while we might often think of bacteria as harmful, remember that many are essential for our health. Our microbiome is a testament to this, acting as a complex ecosystem within us that has a profound influence on our well-being. Imbalances in the microbiome have been linked to conditions ranging from digestive issues to mental health disorders.